As we're doing this for you.
Hey, Leslie.
Hi, Leslie. Hi, Leslie. Okay.
Wow.
So there's going to be a couple different parts to this lab. So this is kind of a summation of everything that we've done. So the first thing that's going to happen is that you're going to start off and you're going to build a cell with aluminum ions. And oddly enough, a strip of aluminum. And then you're going to have some copper ions, and oddly enough, a strip of copper. We're going to have filter paper, one more potassium nitrate. Take your strip of filter paper, soak that in the potassium nitrate, loop that over it, boom, there's your salt bridge. You're going to hook up a voltmeter, okay? Now, for whatever reason, I couldn't find all the voltmeters that we have. The voltmeters are just like they plug into the LabQuest, and you're going to have like a red and black terminal. It really doesn't matter which one you hook them up to, but after you get that hooked up, connect one side to the aluminum, one side to the copper. If you get a negative voltage, just switch them out. Switch the copper and the aluminum so that way you're getting positive. It's the exact same number, but if the negative flips you out, then you get a positive value. So you're going to get a number, okay? It's a number. That's your E value. Now, these voltmeters especially notoriously give readings a little bit lower than they should because these have some internal resistance. So you can have a mathematical model that says, hey, this is what we should get. In reality, and especially since this is going to be a non-standard solution because you're going to have 0.5 molar and 0.5, E naught values are based upon 1 molar solutions. These are going to be 0.5s. So here's what's going to happen. You're going to mix this up. You're going to have it set up. You're also going to need a pH probe, which you're going to plug into your LabQuest. So you're going to take 25 milliliters of a 2 molar solution of sodium nitrate, and you're going to add that to the cell that has the aluminum ions in it. Okay? So you're going to have the aluminum ions, you're going to overload that thing with sodium hydroxide. Okay? What you should see immediately happen is the formation of a precipitate of aluminum hydroxide. So here's what you want to think through. As soon as you see the formation of that aluminum hydroxide, what's going to happen to the concentration of the aluminum ions in the solution? Okay, so just think that through. So you're going to add that, you're going to have your initial voltage, then you're going to record the voltage after you get done, and then the change in the voltage and the change in the pH. So you're going to have your initial pH and you're going to have your initial voltage. Then you're going to add the sodium hydroxide, and then you're going to get the new voltage and the new pH. Obviously, you should see your pH go up greatly because you're dumping a whole bunch of sodium hydroxide into that solution. When you get done with that voltage, okay, so you're going to have that initial voltage, and then you're going to have the voltage when you get done. When you get done with that voltage on line 9, check with me because that has to be above a certain threshold. And if your voltage isn't giving you the right value, then you're going to get KSP values that don't make any sense. Okay? So when you get done with 9 and you record that voltage after you've added the sodium hydroxide, come up, check with me. We might have to do a tweak. Okay? So what you're after on number 10, you're going to determine the aluminum ion concentration. On number 10, let me give you a hint. Start with the Nernst equation over N times the log of, now, let me give you a hint. This is going to be your aluminum ion concentration, okay? And then divided by the concentration of your copper ions, okay? So with that, that copper ion concentration is going to be 0.5 because you're not going to change the concentration of the copper ions. Now, you have to figure out if anything gets squared, cubed, anything like that. So you're going to calculate an E naught value based upon the reduction chart. You're going to look at the reduction potential of aluminum. You're going to look at the reduction potential of copper. E naught is a theoretical value. Okay, that comes off your table. The N is going to come from your balanced equations. Okay, between is your overall. What is your N value going to be? You're going to know the copper ion concentration. You know that you mix that up. That was 0.5. Okay. What you don't know is your aluminum ion concentration. Okay. That's going to be your unknown. So the E value is going to be what you get when after you add in the sodium hydroxide. So this is going to be that reading from number 9. That's the one that you need to check with me to make sure that it's above a certain threshold. Okay? E naught value, theoretical, comes off the chart. N, balanced equation. Copper ions, 0.5. Aluminum ions, that's your unknown value. Okay? Then you want to calculate an experimental value for the aluminum hydroxide. So let me give you a hint. That's going to be your aluminum ion concentration times your hydroxide ion concentration, and then you have to decide, hey, does anything get squared, cubed, something like that. So from number 10, you're going to know your aluminum ion concentration. That's what you found on number 10. How are you going to get your hydroxide ion concentration? You don't know the KSP. You're trying to find an experimental value of KSP.
Take the pH.
Yeah, you're going to know the pH of the solution. Ah, right. If you know the pH, you can calculate the pOH. If you know the pOH, you can calculate the hydroxide ion concentration. So in an ideal world, kind of make a note on this. In an ideal world, your answer to number 11 should be something around 10 to the negative 28th. Okay? That's an ish. Okay? And that's a huge ish with KSP values. Okay? In an ideal world, it would be something around 10 to the negative 28th. But there's a lot of variation on that theme. Okay. So, that pretty much takes you through all of that. Now, here's the other thing. You have today and tomorrow to work on this lab. The other thing that you have to start today is the last page, the tale of the incredibly entropic ions. Now, I need to make one change that I didn't realize this until I went to set up the lab. We don't have magnesium chloride. I didn't realize this. Okay, we do, but it's a hydrated version of it, which would completely screw up all my calculations. So instead of using magnesium chloride, we're going to use calcium chloride. So any point on that lab where it says magnesium chloride, mark out magnesium, and we're going to use calcium. Got heaps of calcium chloride. Got tons of it. No magnesium chloride. Why? What happened to it? I don't know. Maybe somebody took it and sold it on eBay. I'm not sure. So here's what's going to happen. I'm going to give you a weighing dish that's going to have a mixture of magnesium chloride and potassium nitrate. Okay? So this is what you're going to have. What you want to do is figuring out the mass of magnesium chloride that's in that. Calcium chloride. Sorry. Got that in my mind. You want to find the mass of calcium chloride. Oh, that's easy. 0. Here's my answer. There you go, Burkamp. There's your lab right up. 0. So you want to find the mass of the calcium chloride in this mixture. So there's a couple of things that I would suggest that you do. Here's what you can have available to you. You don't know the mass of this. Okay? So one of the things you're going to need is a total mass. So I take that, I scrape that into a weighing dish and find the mass that you have. Okay? Because you're going to need that number. Get the total mass of the system. What do you know about calcium chloride? Soluble or insoluble?
I'm going to guess soluble.
It better be soluble or there's really no point in doing this lab, right? So that's going to be soluble. What about your potassium nitrate? Also soluble. So those are all going to be soluble, right? So when you mix them up together, you're still not going to form a precipitate because calcium nitrate is soluble and potassium chloride is soluble. So once you get it in the water, you're still not going to make anything that makes a precipitate. Like, oh, wow, what can you do? So what we're going to do is we're going to take advantage of the chlorides are all soluble except for what are the two chlorides that are not soluble? Silver and lead. Okay, we're not going to use lead because lead's a horrible thing for the environment. So what's going to happen is that you're going to have available to you 25 milliliters of a 1 molar solution of silver nitrate. You're going to add the silver nitrate to it. What's going to happen?
Precipitate.
You're going to make a precipitate of
Silver chloride.
you're going to make a precipitate of silver chloride. Okay. Then you're going to take a piece of filter paper. Have y'all done filtration before? I need to know this.
No.
Okay. So you're going to have. You should have a funnel like this. You're going to have a round. Huh?
And then you fold it.
Yes, you fold it in half and you fold it again so that it looks like a little triangle like this.
We did that in Chem 1.
You should still
Okay.
you should still explain that, I think.
So take your round piece of filter paper, fold it in half.
But where do we find the filter paper?
You have to bring your own. I've got a whole box of it over there.
Hypothetically, how would I supply a chemistry laboratory with chemicals so we can go to our lab? I'm making fun of Evan.
Hypothetically. Okay. So
He's got the leg crossed there.
I can't. I struggle to do that. I think I just pulled a hammy. Okay.
Someone call the doctor.
Workman's comp.
It's spicy hot.
Okay.
Workers' comp.
So take the filter paper, fold it in half. Fold it in half again. You're going to make a little triangle. You're going to put that in there. Actually, let me just go get one. Stop that for a second.
In the funnel.
So then you're going to fold that open where you have like a nice little cone like this, okay? If you want to get the inside of your funnel wet, then you're going to put that in there, then that should stick to the sides. So you're going to take this, find the mass of it, dissolve it in some water, decide how much water, because again, this is a relatively simple procedure, but you have to write the procedure, okay? So again, this is not near as complicated as the lab, but by the way, if you haven't added in the lab front with the unknown labs, I need that today. So this is a relatively simple procedure, but you need to tell me how much water did you add? Okay, I don't care. How much water did you add? Then you're going to filter this through. Let me give you a hint. You want to wash that precipitate, okay? How much water do you need? It's a pipette. What are you going to do? So what you have to get done today so that this can dry for tomorrow. You don't have to have the procedure, but what you want to do is you want to get that silver chloride precipitate in here. And so when you get done, you want to take a little bit of water, wash that off so that the only thing on there are the silver chloride ions. Then when you get ready, then what you want to do is take that out, and then you want to fold that out and then lay it open like this and put that in your drawer so this thing can dry overnight. So oddly enough, what do you think you're going to have before you start doing anything? Yeah, you got to have the mass of the filter paper so that way you know how much the mass increased. That'll be the increased mass of the silver chloride. Okay? So make sure that you are aware of that. So there's 7 of these. Okay? They're all different. Okay? They're all different masses. But so that's what I would recommend is get that going first. Then do the aluminum nitrate and the other ones. With these probes, I only have 3 of them, okay? But everybody should be in different places enough that that doesn't become an issue because you only need this one time to get that reading. And again, listen to me. When you get that reading on number 9, ask me if that's right, okay? Because if that isn't above the threshold, bad things are going to happen. Okay, let's go do science.